Quick reintroduction, like Howard said, with Solidigm. So I was at Intel for 22 years, sporting a blue shirt, and now I changed the color of my shirt to purple in December. And what I'm showing you guys here is kind of, where the name came from. Hang on a sec. Okay, here we go. Yeah, so basically, 2 years ago, SK Hynix announced that they were going to buy Intel's SSD division, and so together we've come together and formed a new company. So it's operating completely independent. We're calling ourselves Solidigm. We officially started operating as this new company in January, so we've kind of been in an operation for a year. So it's this, I'm about 1 year away from being an Intel employee now. And we, where did the name come from? We kind of combined the words paradigm and solid, so that's where the word Solidigm comes from. But really, I think it was a good match. SK didn't sell a whole lot of data center SSDs. They're very strong in client, very strong in mobile. So our at Intel, our main business was data center SSDs, so that matched very well. Also, to get a little nerdy on you guys, the SSDs are basically contain what we call NAND silicon, which is the transistor-based storage media that stores all the ones and zeros. And the way that they build their storage media is a little bit different than the way we do it. So we specialize in floating gate. They specialize in charge trap. So now we have best of both worlds. And then from a capacity perspective, we had our own fab. They have multiple fabs. So now we can really kind of compete, with the biggest guys out there from a capacity perspective as well. So it's really, I think the combination made a lot of sense. And DataON, like Howard said, has been using Intel hardware for so long, and that's kind of where we fit into the mix. So if you cracked open a DataON server today, you would see that the drives themselves still carry the Intel brand, and they're which is kind of funny because they are being sold by Solidigm now, but physically the SSDs are still branded as Intel. So it's kind of our separation from Intel is slow. We're slowly separating. Even some of the drives that we've launched since separating are still Intel branded drives. But some of the new drives that we're going to start shipping next year will start kind of being rebranded on that physical drive itself. So I just kind of want to point that out. So yeah, I'm Joe from Solidigm, but I'm still in a way selling Intel SSDs. And then on our marketing material, we may call it a Solidigm drive, but we'll put in parentheses formerly Intel, but physically they're still all carrying the Intel brand. So just for fun, I gotta say I've got a little bit of swag. I got a couple. Hold on, let me switch here. Got a couple fancy purple socks. I know you guys would look great in these. So I'm just gonna ask a quick question. So quick question. Not a big deal, but does anyone know what the highest capacity SSD is that we're selling today? Highest capacity Intel branded SSD. If anyone knows it, just shout it out. Not you, Howard.
Come on, guys, please talk.
I think I know.
Hey, you can't guess, Rami. Sorry.
I can't? Oh, man.
Come on, guys, you could do this.
Type it in the chat if you don't know.
Yeah, type in the chat. Ernie, you know.
No, well, I want other people to participate.
Oh, wow, you're so kind.
Oh, wow, okay. Well, very generous of you. Well, okay, I'm going to tell you.
Google, I like it.
All right.
20 terabyte, Nathan says.
Yeah, good.
1.9
Okay.
petabyte.
I'm gonna say we're gonna stop it right there and say Nathan, Steve, Oscar. I'm gonna send the three of you guys some purple socks. All of you are way off, but that's okay.
Wait, I thought everybody gets purple socks, Joe. Whoever's here gets purple socks. What do you mean? You can't do that. You gotta go
You know
buy
what?
more socks.
I could probably swing that. So we'll work that offline.
Everybody get purple socks. Everybody put your email on the
You
chat. Everybody put your email in the chat, and Kelly will send you a note for your address, send you purple socks. Okay? Put your email in the chat, please.
You get socks, and you get socks.
Yes, everybody gets the socks.
All right, good guess, guys. It's 30 terabyte. So we're at 30 terabyte today, and you know, DataON, our 30 terabyte drive is, we call it the P5316. DataON does have a server that supports P5316. So, you know, so if you put, you know, just theoretically, hypothetically, if you put 30 of these 30 terabyte drives in a system, you'd have 1 petabytes in a server. So, you know, eventually these things are going to get pretty dense. Okay, so yeah, so DataON, we've, you know, loved partnering with them for a long time, because they, you know, one thing I could say about the DataON team is that they're always on the leading edge and using the best hardware out there. So, you know, industry leader there. And at Intel, here's one big difference between Intel and Solidigm. At Intel, I was legally constrained from using hyperbole. So I could never, so by hyperbole, I mean I could never say we have the world's best processor or the world's fastest X, because, you know, Intel's a giant company and always getting sued from everyone. So we, as marketeers, could never use hyperbole. But now that we're Solidigm, we're a little looser, and we feel confident, and saying that our latest NVMe drive, our latest TLC NVMe drive, is the industry's most advanced PCI Express Gen 4 product. So we're going through a transition to this drive right now. A lot of the DataON systems have the P5510, and we're transitioning to this 5520. So I just want to give you a couple slides to plug this latest hardware that you're going to see in some of the servers. All right, so here's kind of just a Intel gen-on-gen view. So we're talking now about a PCI Express Gen 4 drive. This 5520 is kind of like a slight tweak, a slight advance from the 5510. You know, the game in the SSD world is adding layers to the silicon. So as you add layers, you can cram more gigabytes, right, into the NAND. And we're up to 144 layers. So it's still, so 5520 is the same NAND media as 5510, but we have upgraded the controller a little bit and optimized it a little bit more. And really, a lot of the special sauce is in the controller, right? The controller is what tells the SSD where to put the data, right? And it kind of controls, in a lot of cases, how fast you can put the data. You know, you can read and write to the media. So we're comparing the last 3 generations, and these percentages are like versus our Gen 3 drive, which was the P4510, and that was our highest selling SSD for years, and it was used in a lot of DataON servers. So that was in gray. And we went to our first Gen 4 144 layer drive was in purple. That's the 5510, and now we have this 5520. So you know, so over here in random performance, you know, your random performance, this is where we included some really cool optimizations in the controller that gave us a really big boost on random read, even compared to this the other PCI Express Gen 4 drive with the same NAND silicon. So this is all controller optimizations. Your random reads are a lot faster with this new generation, and you know, a little bit faster on the random writes and the mixed workloads. And then sequential, you know, you see lesser improvements on sequential versus 5510 but you do see huge improvements versus the Gen 3 drive, and that just has everything to do with the fact that PCI Express Gen 4 is has more bandwidth than Gen 3. But then latency also did improve. So the improvements comparing just PCIe Gen 4 to Gen 4, you know, a lot of those improvements that we got with the 5520 were based on these controller optimizations. So just to get a little more theoretical on you, this is kind of, I'll show you, the next slide is versus competition, which is, I want to back up the statement why we feel like this is the world's most advanced, industry's most advanced TLC SSD. So one thing to keep in mind when designing an SSD, most companies care about what's called four corners performance. So by four corners performance, we mean sequential read, sequential write, random read, random write. Okay, so 100% sequential read, 100% sequential write, or 100% random read or 100% random write. So if you're designing the drive and you're designing the algorithms and the firmware to decide how to read and write, you can really optimize for these four corners, right? And that's really what that tells most of the story. That's what goes on your data sheet mostly. That's what most customers look at. However, if you stop there, you're really missing out, because in the real world, there's a lot of other things that matter, right? So there's quality of service under increasing write pressure. So what that means is you typically don't have 100% of any one type of read or write. You're going to be reading while you're writing. And typically, the more you write to the drive, the slower your reads get. So you want to be able to maintain those read speeds as you're increasing that write pressure on the drive. Also, you're doing garbage collection. You're moving data around, wear leveling and whatnot. You want to be able to do that in a smart way, right? The other thing is, like, you may be running multiple virtual machines on a server. You have multiple tenants, noisy neighbor type of problems, and you want to be able to account for that. As well as if you put like a kind of a storage analyzer on your server, you're basically queuing up reads and writes at any given time. And typically when we talk about random read and random write performance, we're talking about very high queue depths. But the reality is, if you look at a server running in the real world, running multiple types of workloads, on average, you're typically operating at a queue depth of around 12, 18 type of queue depth. That's the real world queue depth. That's how many reads, writes have been queued up in the real world. You're rarely operating at a queue depth of 100, couple hundred something. So what I'm saying is, to toot our horn a little bit, our engineers, I think, go to the next level to really optimize for real world performance. And you can look at, here's one example. So let me explain what you're looking at here. Lower is better. And so we're showing the 5520 in purple compared to a comp drive in orange. And we're showing latency. You want low latency, right? You want a quick, the time it takes to get a read. All right. So you ask for a read, and how quickly do you get it back? So as you increase that write pressure, it's hard to get a consistently low read time, right? And so as you can see here, we feel like we do it better than others when it comes to mixed workloads. Not just four corner performance. As you're mixing in more and more writes, we can continue to deliver that consistently low latency read. So you're going to get that low latency read 99.99% of the time, which is what quality of service is. So that so the 40% number really kind of is pretty powerful when you and really this translates more to real world. The one last slide I have here is that Storage Review did a good review very recently on this 4520. You can Google it up, and they benchmarked the 5520 versus like 6 other drives, all of our top competitors. We do really well in four corners. We don't win it all, but they look at real world applications and in here lower in the article. And we're in several of those, we really crush the competition, and it really starts to stand out. So very competitive in four corners performance, but in the real world applications, this SSD really shines. So we're very, very proud of it. And we definitely expect this to be kind of our highest selling drive, by the within the next quarter or two. So something we're pretty excited about.